Okay, hello everyone. Today's session, module 8, we look at dynamic address assignment for IP version 6. So we'll look at stateless auto configuration, SLAAC, and we'll look at DHCP version 6. After we did version 4, I think version 4 is much less complicated. If you want to dynamically assign an address, then you just use DHCP. For version 6, we have a couple of methods on how that process works. We have stateless auto configuration only. We have SLAAC with stateless DHCP. Then we have DHCP. I think in CCNA 1, part of this was covered when we did module 12, where we did the introduction to IP version 6. So here, I don't think it's a lot added after that CCNA 1 module. And this is SLAAC and DHCP version 6. Our objectives are to explain how IP version 6 hosts acquire IPv6 configuration. Then we go through the process and operation of stateless auto configuration, explain the operation of DHCP version 6, then look at how we configure a stateful and a stateless DHCP version 6 server. I think we also look at how a client is also configured at this stage. Right. So with what we did with DHCP version 4, I think we already discussed the issue to do with manual configurations being time consuming. It requires a lot of time. Imagine if you have 100 devices in your very small network, you have to manually configure one by one the IP addresses. With this manual configuration, there's also an issue to do with errors, especially with IPv6. IPv4, I think it's quite simple. We're used to decimal numbers, but I don't think all of us are used to these hexadecimal values. So errors are definitely bound to happen if you manually configure devices hosts in a network. So that said, that's the reason basically why we have dynamic address assignment. And here we look for we are looking for the one which involves the IP version 6. If automatic IPv6 address is selected, the host will use the ICMP version 6 RA messages to help it configure an IPv6 configuration. Right. A host, uh, when we did module 12 of CCNA 1, we discussed the issue to do with the host having both. Right. We discussed the a host having both the GUA and the link local address. So every host, with respect to IPv6, it has two addresses. We have the GUA and we have the link local addresses. the GUA being a global unicast address, which allows us to globally route across networks. Then with the link local address, allowing communication within a local link. That said, we also introduced RA messages and RS messages, which are type of ICMP version 6 messages, which as well help us in the configuration of IPv6 addresses. So in the client server module, which is used by DHCP version 6, we realize a client can either send an RS, a router solicitation message requesting for IP address information. Then the server can respond with an RA message, which contains the information to do with how that client is going to get an IPv6 address. So basically, this is sort of a background of how IPv6 addresses come about. So from two types of addresses, GUA link local, we also have two types of messages, RA, RS, which are used in assisting the configuration of IPv6 addresses. By default, an IPv6 enabled router sends RA messages, which simplifies how a host can dynamically create or acquire its configuration. A host can dynamically be assigned a GUA using stateless and stateful services. I think we're going to be looking a bit much on what stateless and stateful services are. All stateless and stateful methods in this module use RA messages to suggest how to create or acquire its IPv6 configuration. Although hosts operating systems follow the suggestions of the RA, the actual decision is up to the host. All right. So here we are just looking at how a host can dynamically be assigned a global unicast address, either using stateless or stateful services. And when we talk of stateless services, we basically mean the server, okay, it's right there. The server is not tracking, no device is tracking the assignment of the IPv6 addresses. The server is not monitoring the assignment of IPv6 addresses. So the DHCP server does not know which addresses are being assigned to the host. That is when we have stateless services. So an example that we have that uses stateless services is the one which has SLAAC with DHCP. When we have SLAAC with the DHCP, this is usually SLAAC with stateless DHCP. The reason why is because this server is not responsible for the actual assignment of IP addresses. It's only there to provide additional information which is required by a host. So in this example, SLAAC is the one which is responsible for assigning the address, the IPv6 address. In this one, the server is just there for providing other information, the DNS server. That is the other information that is required there. So when we talk of stateless, it basically means the server is not tracking, it's not monitoring which addresses are being assigned to which hosts. Then when we talk of stateful, the server is managing the assignment of IPv6 addresses. So when we talk of stateful, it means the server knows every address that is being assigned to every other host. It is tracking, it is monitoring everything. So when we have stateful DHCP, we only have DHCP server being responsible for everything. We don't have SLAAC being part of that. So to summarize, the three methods that we have We have one which has SLAAC only. Then we have SLAAC with stateless DHCP. Then we have lastly this third one, which is DHCP, stateful. So these are the three ways how a GUA, global unicast address, can be assigned. Right. Three RA message flags. So I discussed the issue to do with the RA message having information on how a client is supposed to configure its IPv6 address. So if I take a look at this example, this is our client and this is our server. When a client wants to request information to do with IPv6 addressing, it sends an RS message. Here is highlighted, I need an RA from R1. So an RS, router solicitation, is basically asking, I'm new to the network, I need an IPv6 address. The router, which is acting as the server in this case, responds. It responds with an RA message. An RA message will contain values which gives us an idea of how the client is going to configure its address. So for those values, we have what we call flags. We have the A flag, which is the autonomous address configuration flag, the address auto configuration flag. And this one signifies that we are going to be using SLAAC. So if we have value of A is equals to 0, let's use 1. If we have a value of A is equals to 1 on our flag, for example here, it basically means the instruction is we are going to be using stateless auto configuration. And by default, as you can see, the value of A is 1 on all devices, on all routers. By default, they use SLAAC only. So the value of A is equal to 1. Then we have other values. We have the O value, which is the other configuration flag. So this one basically instructs hosts that they're using a stateless DHCP for other configurations. So amongst the three methods that we listed, so we have SLAAC only. How do I put this? Let me put it here. So we have SLAAC only, and we have SLAAC with DHCP. Then we have DHCP stateful, DHCP version 6. So this is state, this is stateless. Right. Then I'm going to give as our three flags, we have the A flag, we have the O flag, and we have the M. So the A is for address auto configuration. If that value is 1, then we are using SLAAC. The O is for stateless, making use of the stateless DHCP for other configuration. If that value is 1, it means we are using the DHCP server for other configurations. Then the last one is M, the managed address configuration flag. This one is basically instructing we are using a stateful DHCP server for everything. So if the flags come with, let's start with SLAAC only. The flag will come with 1, 0, 0. What does it mean? It means we are using SLAAC and SLAAC only. And if it comes with 1, 1, 0, for example, it means we are using SLAAC to get our IPv6 address, but for other configurations, our O, we are using a stateless DHCP. And if it comes with a 1 here, here it will come with a 0. Here it can either be a 1 or it can be a 0. Everything will be overridden by this one. This means we have a stateful DHCP. So depending on the values that are on these flags, when the RA comes, the RA message is the one which contains these flags. So depending on the values of those flags, the host will then be able to choose, this is how I'm going to be assigning an IPv6 address to myself. Right. There is a point I just missed here. This is very important. Although host operating systems follow the suggestion of the RA, the actual decision is ultimately up to the host. So the RA message, it has suggestions of how a host can configure its IPv6 address. It can either use SLAAC, it can either use SLAAC with its stateless DHCP, it can either use stateful DHCP. However, the ultimate decision will remain with the host, depending on the operating system of the host. For example, we have operating systems which says we should use SLAAC only. So what it means, every time there is a suggestion, that operating system will always pick SLAAC only. There are others which chooses to use stateful DHCP. Then from the suggestions, depending on the operating system of the host, it will pick one of those methods to configure its IPv6 address. So I think what's important to get here is the meaning of those flags and the values that they have. If you have SLAAC, what are the values of the A flag, the O flag, and the M flag? For stateless and for stateful DHCP respectively. I think that is what you need to understand. SLAAC overview. Not every network has access to a server, but every device needs a global unicast address. The SLAAC method enables hosts to create their own unique address without services of a server. Right. SLAAC sends periodic RA message every 200 seconds. How much is that? 200 seconds, approximately 30. That's 30 what? Divided by 6. That's 30 minutes. 3 minutes. So that's approximately 3 minutes. It's not a lot. So RA messages are being sent periodically after every 200 seconds. You need to get these numbers to stick because these are the typical questions that you get. What is the period of what is the period that a router sends RA messages? 200 seconds. So it sends periodic RA messages providing addressing and other configurations. Okay. A host can send an RS message requesting an RA. SLAAC can be deployed as SLAAC only or a SLAAC with DHCP. SLAAC with DHCP, this is stateless DHCP. Right. I think this is an overview of what we've already discussed. SLAAC, it makes use of no DHCP server. So in a case where in our network we don't have a server, it does not mean we do not need addresses. It does not mean we also do not need dynamic assignment of those addresses. So SLAAC, make no mistake, SLAAC is not manually assigning addresses. It is a way of dynamically assigning addresses. But now, provided that we do not have a server, then how do we dynamically assign addresses? That's why we have SLAAC. So SLAAC allows us to get an RA message From the RIA message, we get the prefix, the global routing prefix, which is the network portion. In IPv4, this is the network portion. So from the RIA message, we get this network portion. Then we add either randomly or by using the EUI64 value, which makes use of the MAC address, this one. So this is a way of dynamically assigning an address without needing a server. Overview of SLAAC. Enabling of SLAAC. Right, so to enable SLAAC, stateless auto configuration, you just need to configure an IPv6 address on a router, and that's it. So take, for example, this router here. To enable SLAAC on this router here, you just configure this GUA, then you configure this link local address, and basically that's it. That's how you enable SLAAC on a router. Now, what it means, this router will now be sending RA messages, which will allow this host to get an IPv6 address by using SLAAC. So enabling SLAAC here is basically enabling a router to provide addresses using stateless auto configuration. It needs to be enabled. And this is why it's called default. The reason why is because you just configure the IP addresses. You just configure the link local address and the GUI and the GUA address. So it's as simple as that. To enable SLAAC, just configure addresses on the interface. Then that router will start acting as a SLAAC enabled router. Right, enabling SLAAC continued. So when you enable SLAAC, two things happen. That router is added to this multicast group. Just right. So when we enable SLAAC, there are two things that happen. One, got a question. Yes, I'm back. Right. So when we enable SLAAC, two things happen. One, our router is automatically added to this group. This is a multicast group for routers. All routers, when they are enabled, if SLAAC is enabled in this example, then it automatically joins this group. How is that important? It's important when a client wants to send an RS message. Which address does it use? It uses this destination address. Why? Because it is sending to all the SLAAC enabled routers on the link. So when you enable SLAAC on a router, it will automatically join this group, which allows a client, in this case, if this one wants to send an RS, its destination will be FF022, meaning it will be sending to all SLAAC enabled routers on the link. Another thing that happens when we enable SLAAC, it means every RA message which is being sent from the router will be sent to this multicast group here. This multicast group is what we call the all node group, which is the broadcast version of IPv6. So recognize these multicast groups. I think they're becoming important at this stage. This one is for routers. Then this one is for hosts. Right. SLAAC only method. RA messages from R1 have the following flags. I think we've discussed this. If we have SLAAC only, it means our A, our O, our M, this is a 1, this is a 0, this is a 0. That is basically what SLAAC means. And I think this is what is being shown by this slide. Informs the client that to also use the additional information in the RA message, that is the DNA and default gateway information. Excuse me. Right. So for the SLAAC only method, our RA message and the information in the flags will be looking like this. And if you go to show the information of the IP addresses, it will confirm that the GUA was generated, PC1 is generated in IPv6 GUA. I'm sure this would be an A, using the R1 RA. How are we confirming that? We could confirm that by using this. One, two, three, four, 16, 16, 16, 16. All right, so this is 64. Right. So if you look at the value of the IPv6 address of this PC. So this is IP config of this PC, and it is giving us the IPv6 address. If you look at this value that I have highlighted, it is going to be the same as this value that is here. The reason why is because if we are using SLAAC only, then it will get this network prefix from the router and it will generate randomly the other part right here. That's a random generation. I'll assume that's a random generation because I cannot see the MAC address. So it can either be generated randomly or by using the MAC address via the EUI64 process. RS messages. I think some of these slides will sound sort of a repetition. A router sends RA messages every 200 seconds or when it receives an RS message. IPv6 enabled hosts wishing to obtain IPv6 addressing information sends an RS message to all routers. Multicast address of FF02. I think we looked at this already. So if a host wants to obtain an address, it will send an RS to this group. And this group contains all routers, all IPv6 enabled routers on the link. So if PC1 is just booted and sends an RS message to all routers, R1 generates an RA and then sends it back to the all node multicast address. I think we've discussed this already. So this one sends an RS message, and this RS message is addressed to this group. Then the response is addressed to this group. This group is the all node multicast. And this group is the all routers multicast group. And basically, those are the RS messages and as well the RA messages that we have. Host process to generate interface ID. Using SLAAC, a host requires its 64-bit subnet information from the router and must generate the remainder. I think we've touched on this already. How is the interface ID, which is the host portion, how is it generated? So if I'm using SLAAC only, the first 64 bits, this is the prefix of the global routing prefix, basically. The network portion, this is what we get if we are using SLAAC only. The rest of the 64 bits that make up the IPv6 address, this is either generated randomly or by using the EUI64 process. Random is the word. EUI64, like I said, it uses the MAC address. I think we discussed this in module 12 of IPv6 as well. You just take the MAC address, you find the middle point, you add, I think it should be FF, FE, you add that in the middle, then you flip the 7th bit. That's how you get these 64 bits. Because the MAC address, it has 48 bits. If you add FFFE, which is 16 bits, 48 plus 16 should give you a total of 64 bits. So this is sort of revision, I would think. This is how the interface ID is generated. Then we have the duplicate address detection. This is a method which hosts used to see if an address is unique. So after a host has been given an IPv6 address via the three methods discussed, it will perform the duplicate address detection. So what is that? In simple terms, an NS is sent by the client. So a client sends an NS. And what does this NS contains? It just contains, I have this IPv6 address. Does someone else has it? Then that NS it sends to the O node. Every host on the local link will receive that message. Then the response, the NA, if you get a response, then it means your address is not unique because you sent an NS asking if someone has this specific address. If you get a response, then it means your address is not unique. Then the process of getting another IPv6 address starts. If you do not get a response, then it means that address is unique. So that is basically what duplicate address detection is. To note, duplicate address detection is not required because a 64-bit ID provides 18 quintillion possibilities. Therefore, the chance of a duplicate address is remote. However, the IETF recommends that duplicate address detection is used. So basically here is being highlighted IPv6, it has a lot of addresses. So we shouldn't worry about having duplicate addresses. But we still need, according to the regulations, we still need to use duplicate address detection. What to get here? We have the NS, we have the NA. The NS is sent by a client to check if any other device is sent by a host to check if any other host has a specific given IPv6 address. Then if you get an NA, that's a problem. If you do not get an NA, then everything is perfect. DHCP version 6 operation steps. Now, we've discussed SLAAC only. With SLAAC only, we said we get the routing prefix from the network. Right. 3 minutes left on my end. Taking out of the time. Thank you. All right. With SLAAC only, we discussed we get the global routing prefix which is the network portion, we get it from the RA message. That's 64 bits. The other 64 bits, we get it from the EUI64 process or random. With the DHCP version 6, we also have a process. How do we get our address? So let's start with DHCP version 6 stateful. I think that one is described on this image. So if we are using DHCP version 6 stateful, this is our client. It sends an RS message to the router. Our router responds with an RA. The RA contains information of how a device is going to configure its IPv6 address. Depending on the operating system here, it will choose from the three methods. If the operating system says we choose stateful DHCP, then what happens after? We go to step 3, where a solicit message is sent to the server now. So this is the start of negotiations between our client and our DHCP server. We don't have an IPv6 address yet. We ask for negotiations with this server by sending the solicit message. The server responds with an advertise, which is basically saying, let's negotiate. We have a room to negotiate. We can offer you an IPv6 address. Then we have a request where our host is now requesting an address. We get a reply where our server is offering an IPv6 address. So this one is stateful DHCP. We are getting our address and every other information from this message here, the reply message. That is what gives us everything. If we were using stateless, what will happen? This will happen, this will happen. Then this RA message will contain our SLAAC, how we get our IPv6 address. Then this will happen, but on this request, we only request for other information. We don't request for everything. And basically that is what stateless DHCP is. Let me continue there. I can see my time is up. Let me continue right on this slide. Use the same link.